So I changed my mind and I decided that I will talk a little bit more about shear, some shear behavior. Okay, so first thing is just a little bit of common sense. So here's this beam, okay, and we're gonna shear it, and it's gonna crack at 45 degrees. And so let's say you put a stirrup here, and you put a stirrup there, that's not going to do you any good. Can you see the right half is going to fall down relative to the left half? You need to have a stirrup that crosses that crack. So if you space them too far apart, you're going to miss the crack. Now, this crack usually is at about 45 degrees. Okay? So to make sure that you get a stirrup across there, if this distance is D, because it's 45 degrees, that distance is D. And so if you space them more than D apart, you have a chance, if you're unlucky, you're going to miss it. So to be safe, we're going to say D over 2. So the spacing has to be less than D over 2. We call this D over 2 spacing max, or S max. Okay, so you got to make sure of that. Don't put your stirrups more than D over 2 apart. The other thing is, I guess you could intuitively see that after this crack, if I put like a hair of steel, just very little, as soon as you crack it, you're going to snap the stirrup. There's a minimum amount of stirrup that you need to have in order to guarantee that the stirrup will hold once the beam cracks, and that's called AV for shear, AV min. Okay, so you have S max and AV min. And then finally, what we're gonna do, and I don't know how true this is, but we're going to say the shear strength of a reinforced concrete beam, okay? And N stands for nominal. Anytime you have a strength, the shear strength is Vn, the moment strength is Mn. I'll let you guess what the torsional strength is. Yep, Tn. But anyway, the shear strength, we're going to say, is made up of a concrete part plus a steel part. Now, the concrete part is related to the tensile strength of the concrete, because remember, when you're shearing the concrete, you're actually breaking it in tension across that diagonal cracks. We say diagonal tension strength. And so we learned in 3210 that the tensile strength is like 6.7, 7.1 square root of F prime C. So this concrete shear strength, let me get rid of these other two here. This concrete shear strength is a function of the square root of F prime C. I promised we wouldn't have any equations, but I might as well just do this. This is the equation. That's the area. That's the strength. Because it's tensile strength, it's square root of F prime C, and there's a constant in front. The shear strength due to steel is just going to be, here we have this stirrup, okay, and you're pulling it. And so you're just going to get the area of the stirrup, AV, times FY. And that's how much each stirrup holds. And then you're going to have to count how many stirrups cross that crack. And if you can figure it out. If the length is D, okay, that's this distance here, D, and you space them every S, you have D divided by S is the number of stirrups crossing that crack, and this will be VS. So sorry, another equation. Okay, so I wanted to add that in and a couple other things about shear behavior. If you bring this load closer and closer to the support, eventually what's going to happen, you get this load so close, so let me make them red. You get this load so close to the support that this thing is going to break like a split cylinder. So you remember this test that we did in 3210 civil engineering materials? We took these cylinders and we put them on the side. Remember that? We called it the split cylinder test or Brazilian test. And remember how these things just cracked right in half? Um, that's going to happen right there. And this is actually stronger than the diagonal tension shear strength. And so when you bring the two loads closer together, the apparent shear strength goes up. And the last behavior thing about shear I want to talk about, there is a case when you can shear concrete just like how the scissor shears the paper. If you put the loads really close together, okay, so on a column, sometimes you have a little stub sticking out. It's called a corbel, and that load is there. This distance is so short that this can shear vertically right like that. I'm getting red. So you can get a vertical shear crack in this kind of situation. And we'll talk about this very special case when we design these corbels in this class. Okay, I think that's more than enough for shear right now. The next thing I'm going to talk about is bar cutoffs, which might be one of the most complicated things in this class.